We're on problem 141. On Jane's credit card account, the average daily balance for 30-day billing cycle. When I see these long paragraphs, it starts to give you a headache. The average daily balance for 30-day billing cycle is the average of the daily balances at the end of each of the 30 days. Okay, so they take the average balance of each of the days and then they average it. Okay. At the beginning of a certain 30-day billing cycle, Jane's credit card account had a balance of $600 at the beginning. So what problem was this? This was 141. So at the beginning, she had a balance of $600. Fair enough. Jane made a payment of $300 on the account during the billing cycle. So this is the beginning of the month. And then at some point, this is 30 days later, at some point, she made a $300 payment. Fair enough. Continuing. If no other amounts were added or subtracted from the account during the billing cycle, what was the average daily balance on Jane's account for the billing cycle? Okay, so I think I'm visualizing this right. If we say that this is days, where this is day 0 and this is day 30. So essentially, at the end of every day, so at the end of day 1, so at the beginning of a certain billing cycle, Jane's credit card account had a balance of 600. So we don't know. She might have paid it on day 1. So I'm not going to put any labels here. But she starts at 600, and that's her balance until someday, at the beginning of Jane's, on some day, she pays off half of it, and her balance goes down like that. So the question is, what is the average? So it's going to be $600 times a certain number of days plus $300 times a certain number of days divided by 30. So let me write that down. The average is going to be equal to 600 times however many days she carried the 600 balance plus 300 times however many days she kept the 300 balance. And that's going to be 30 minus x. 30 minus x, right? If she kept the $600, if she paid after 15 days, she would have had the $600 balance for 15 days. And then she would have had the $300 for the remainder of the days. If she paid after 1 day, then you would have the $300 balance for 29 days. And all of that divided by 30. That's the average. And I try to do that from the get-go because I just want to get kind of my algebraic brain around the problem so it becomes less abstract. So statement number 1. Statement number 1. Let me keep that on the screen. Statement number 1 tells us Jane's payment cycle was credited on the 21st day of the billing cycle. 21st day. Credited on the 21st day. So that means that she had a that x in this example, that she had a $600 balance for 20 days. And then on the 21st day, her balance would have gone to 300. So the average is going to be equal to 600. She had a $600 balance for the first 20 days times 20 plus 300 times the remainder days, right? 30, so 300 for 10 days. And that's all divided by the number of days. So statement 1 alone is enough to figure out her average balance for the month. Statement 2. The average daily balance through the 25th day of the billing cycle was $540. This is interesting. So 540 is the average through the 25th day. So if we average the first 25 days, so her balance was 600 for x days plus 300 for the remainder, only in the first 25 days. So it's x minus 25. So you can actually take this equation and solve for x. It's actually a linear equation, and I'm sure this time multiply both sides by 25, you get a number, and then you can distribute this out, add all the x terms, solve for x. And then once you solve for x, you can just use this equation up here to figure out the average daily balance for 30 days. So actually, each of these statements independently are sufficient to figure out this problem. And actually, it was very critical that we kind of thought about it in this term from the get-go. Otherwise, this would have been a very hard problem to get your hand around. But this is interesting. I strangely really like that problem. Anyway, next problem, 142. 142. If x is an integer, they're asking is 9 to the x plus 9 to the minus x equal to b? Who knows? Problem 1 says 3 to the x plus 3 to the minus x is equal to the square root of b plus 2. So right from the get-go, I don't see, I mean, there's 3's, there's 9's, there seems to be some relationship. Let's square both sides of this equation and see if it can reduce to something that's useful here. So the right-hand side is equal to the left-hand side, so you get 3, if you square it, you get 3 to the 2x, and then you get plus 2 times these multiplied by each other. 3 to the x, 3 to the minus x, plus 3 to the minus 2x is equal to b plus 2. I just squared both sides. 3 to the x times 3 to the minus x, that just equals 1, right? You could add the exponents. That's equal to 3 to the 0. That equals 1. Or you could view that as 3 to the x divided by 3 to the x. Either way, that equals 1. Then you're left with 2 on both sides of the equation, so you can get rid of that. So then we're left with 3 to the 2x plus 3 to the minus 2x is equal to b. But then we could rewrite this. Think about this. 3 to the 2x, that's the same thing as 3 squared to the x. And this is the same thing as 3 to the minus 2 to the x is equal to b. And I think now your bells are ringing in your head. 3 squared, that's the same thing as 9 to the x plus, so I should do 3 squared to the minus x, that's easier, plus 9 to the minus x is equal to b. So statement number 1 actually reduced to what we were trying to prove. So statement number 1, at least alone, is sufficient. Let's see what statement number 2 gets us. Statement number 2 says x is greater than 0 is equal to b. X is greater than 0 is equal to b. So let's see. The original was 9 to the x plus 9 to the minus x is equal to b. So they're now saying that b is equal to 0. So how does that help us? If b is equal to 0, let's subtract 9 to the minus x from both sides. So you get 9 to the x is equal to minus 9 to the minus x. Now let me multiply both sides by, negative 9 to the x. So then you get, let's see, I just want to make this minus 9 to the x times minus 9 to the x. I'm just trying to simplify it. So what do you have here? The minus sign, minus 9 to the 2x, right? Just add the exponents, is equal to, minus times a minus is a positive, and then a minus x and a positive x. Add them together, you get 0, so 9 and 0 is 1. So that simplifies to minus 9 to the 2x is equal to 1. Minus 9 to the 2x is equal to 1. So can this ever be true? Can this ever be true? Let me think about that. The only way something that's non-1 or non-negative 1, the only way that when you raise it to a power, you can get a 1 is if you raise it to a 0th power. So this is only true. This is only true if x is equal to 0. But they tell us that x is greater than 0. So actually, this is an interesting case. Using the information they gave us in problem number 2, actually, I just want to make sure I'm not missing. So statement 1 was sufficient. So can we prove? Well, we don't have enough information to prove the statement. We have enough information to disprove the statement, but not to prove it. So I'm going to stick with A. I was going to say that we can say whether the statement is true or false, but we definitely don't have enough information with just statement B to prove. And I'm right. So they want to know, right, you have to be able to prove the statement is true. Statement B, the statement 2 actually proves that it is false. It doesn't prove that it's true. It answers the question but says no. So statement 1 alone is sufficient to say that that statement is true. And I'll continue in the next video.